Welcome back, everyone. Here are 5 more difficult questions, starting with 2 unique ones. The first question is log base 10 of x. For this question, we need to remember the laws of logarithms, in particular, the base change rule. We are most familiar with the ln function, or log base e, so we change our bases to that. Hence, the function can be rewritten as ln x over ln 10. Now we will integrate using by parts, choosing ln x as u and 1 over ln 10 dx as dv. We know that 1 over ln 10 is just a constant, but if you know how to integrate ln x, this should make sense. Using integration by parts this way will help us integrate this equation easily. Since u is ln x, then du over dx will be 1 over x, and du will equal 1 over x dx. Similarly, dv is 1 over ln 10 dx, which makes v equal to 1x over ln 10. Plugging in values into the integration by parts formula we get ln x times x over ln 10 minus the integral of x over ln 10 times 1 over x dx. The x here cancel out. Simplifying gives x ln x over ln 10 minus the integral of 1 over ln 10, which just gives us x over ln 10 plus c. We can take x over ln 10 common, and inside the brackets are left with ln x minus 1, and plus c. This is our final answer. Next, we have the function 2 raised to power ln x dx. Whenever you have a question in this form, it is best to rewrite this. We write this as e power ln 2 power ln x. Since ln and e are inverses, this is an equivalent expression. Now, due to the logarithmic properties, we can bring the power ln x forward and multiply it to get e power ln x times ln 2. Now, to make this easier to see, we can write this in brackets. E to the power ln x is the equivalent of x, so we write this as x raised to the power ln 2.
ln 2 is just a constant, right? So, can we use the power rule of integration?
Exactly. Evaluating this gives us the answer x power ln 2 plus 1 divided by ln 2 plus 1 plus c, which is just our final answer. Moving on to a little more difficult one. Integrate cos 2x over 1 minus cos squared 2x dx.
I want to say it looks difficult, but it really doesn't, which is weird.
Seems like you're catching on. In fact, this is not difficult at all, so I recommend you solve it.
All right, I'd start with using a trig identity and write 1 minus cos squared as sine squared. This way it looks easier. I feel like I can use u substitution now with u as sine 2x.
Is that the option you want to go with? I would recommend trying to simplify further. It might make it even easier.
Okay, how about I write the sine squared as sine 2x times sine 2x. Now cos 2x over sine 2x is just cot 2x, and 1 over sine 2x is cosecant 2x. Okay, how do we integrate this now?
How about using the trick?
I got it! An integral is just an antiderivative, so I need to find a function that gives a derivative equal to this. And for a fact, I know that the derivative of cosecant x is negative cosecant x cot x. But we have the angle 2x, and when taking the derivative, we multiply the angle with the function. So to compensate, I will multiply this by 1 over 2. And put a negative sign with it to get positive on the other side. Therefore, giving the answer negative 1/2 cosecant 2x plus c.
Let's combine logarithms and trig functions for the next question. Integrate 2 sin x times ln secant x dx. Which method to use?
Two terms are being multiplied, so the only options are u substitution or integration by parts. Since the trigonometric terms are sine and secant, we cannot establish any relationship between them by using u substitution. So, we have to resort to integration by parts.
Exactly. Now to choose values for dv and u. ln secant x will have a complicated integral. However, its derivative can be evaluated using chain rule. Du over dx is just 1 over secant x times secant x tan x. Then the secant x's can cancel out, simply giving tan x dv is given as 2 sine x dx, making v equal to negative 2 cos x. We can plug our values into the formula, negative 2 cos x times ln secant x, minus the integral of negative 2 cos x times tan x dx. The two negatives make a positive. Since tan equals sine over cos, then rearranging this tells that cos x times tan x is just sine x. This can now be evaluated to give the final answer, negative 2 cos x times ln secant x minus 2 cos x plus c. Last question, let's do one with exponential and trig functions. We will be solving the integral of e power cos x times sine 2x. First of all, we expand the sine 2x to give 2 sine x cos x. Now we can do this using either integration by parts or u substitution. Both methods work. Which one do you want to try?
U substitution seems easier, so can we try that? Substituting u as cos x.
All right, so let's solve it using integration by parts.
That's mean!
Since you already know how to solve using u substitution, then it's better to learn the other method. You might learn new tricks this way. So how about you take a try integrating this by parts?
Okay. Let's choose dv as e power cos x times sine x dx. Since this way, we might be able to cancel terms out. Then u should be 2 cos x.
Very well, let's give it a go. Du over dx will equal negative 2 sine x. Therefore, du equals negative 2 sine x dx. Now, to integrate dv, we need to use u substitution and choose u as cos x, since it is in the exponent. Then du over dx is negative sine x, and dx is negative du over sine x. Plugging it back in, we get e power u times sine x times negative du over sine x. The sine x cancel out. We can write the negative outside of the integration sign, and integrating e power u just gives e power u. Converting this back in terms of x, we have negative e power cos x. Using the integration by parts formula now, we plug in the value of u times v minus the integral of v times du.
Wait, another tricky integral? Oh, never mind, I see it. This is the same integral for dv, so we just use that.
Good observation, we use that. This turns our expression into negative 2 e power cos x times cos x minus negative 2e raised to the power cos x. The two negatives make a positive. We take 2 e power cos x common now, and what's left in brackets is 1 minus cos x, and that is our final answer.
Wait, you forgot to add the constant.
Oh, you're right. All right, there we go. Plus c and plus c.